you've got a couple bags of coffee and you're taking those bags of coffee and you're throwing them together and making a third bag of coffee. So there's different attributes to that coffee. Okay, so coffee A, we have how many pounds of it that we've bought, and we have how much it is a pound, and then we could also talk about how much that bag costs. So there's 3 different numbers attributed to type A coffee. I'm going to let my number of pounds be what my variable is. So type A, and maybe that's obvious to you, but I'm just going to say that anyways. I'll let little a be the number of pounds of type A, and I'll let little b be the number of pounds of type B coffee. And I know that type A coffee costs $4.55 a pound. And I know that type B coffee costs $5.90 a pound. So I want to stop and think about for a second. So 8 pounds of coffee A will cost how much? So I don't know a number, but I can write an expression. And if I'm not sure, one of the tricks, I'll show you a little bit of a trick. So I can pretend that I am buying 10 pounds of coffee A. So that 10 pounds costs how much?
It would be $45.
Right. So I oftentimes see that is quick for you guys to do. Let's deconstruct that. Where did you get the $45.50?
I multiplied $4.55 times 10.
Okay. But that 10 was our A, right?
Mm-hmm.
Okay. So if I have A pounds, my expression is going to be that I have 455 times A.
Okay.
Okay. So that entire expression, when I read that, when I write it on my paper, I don't read it as 4.55A. I read it as the cost for my A bag of coffee. Okay.
Mm-hmm.
So then I also can do the same thing for B. So B pounds of coffee, and it's coffee B, is going to cost how much? So again, I want an expression. I don't want a number.
Oh, would it be 590B?
Right.
Okay.
If I don't know how much B is, I certainly can't say how much the bag costs, right?
Right.
It's impossible. I'm just looking for an expression right now. Is there another number here that I've not used yet? I know that I want 180 pounds of the blend. So the blend, so when I put those two bags together, make a third bag, the blend has 180 pounds in it. So A is a number of pounds. A is how many pounds was in the first bag. B is the number of pounds that was in the second bag. And so one of the things to be careful is to make sure that you're comparing apples to apples. So if A is pounds and B is pounds, let's compare it to 180 because 180 is also a number of pounds. And what's the relationship between A, B, and 180? Can I write an equation? Can I put symbols in there and connect those and make an equation? So pretend that A is 10 and B is 20. How many pounds of coffee do we have in our blend?
30.
Right. So could my answer have been 10 and 20?
No.
Okay. So what did you do to A and B? What did you do to 10 and 20?
I added them.
Okay. So what do we want to do to A and B?
Add them.
We want to add them. And we know the answer is supposed to be
180.
Right. So I know that $4.55 times A, whatever A is, that gives me a number, and that's the cost of bag A. And I know that $5.90 times B, that's the cost of bag B. But I'm throwing those 2 bags together and I'm making a third bag out of the first 2 bags. And it tells me that my blend is going to be $947.25. $947.25. Did I read that right?
Yeah.
So this is the cost of the blend. So this is the blend bag, let's say. Okay. So what should be the relationship between those three numbers? So think about it. Just think about it. You've got this bag.
Mm-hmm.
You've got a bag of coffee. You've got another bag of coffee.
Right.
It's a number. I don't know what this number is, but it's a number.
Mm-hmm.
This is the cost of this bag of coffee. This is the cost of this bag of coffee. How many bags of coffee are you actually buying when you're checking out? Let's pretend. Let's go back to my pretend situation. So A was 10. B is 20. That means that I spent $45.50 for bag A. And I spent, I guess it's going to have to be like $118, right? 59 times 2. I spent $118 on bag B. What was the total spent? How much did I check out for?
$163 around there.
Yeah. Okay. Again, I don't care about the specific number, but
Right.
more about how did I get that number. So my
Right.
Okay. So what did you do? You took the 45, you took the 4 cat 55 and multiplied it by 10.
Yes.
And then you took the 5.9, multiplied it by 20.
Mm-hmm.
And then what did you do to those two numbers?
I added them.
Okay. So what happens over here? If you add the cost for the one bag to the cost of the other bag,
Mm-hmm.
how are those two numbers supposed to relate to the $947? This is how much your two bags is supposed to cost total.
Right.
This is just equal. And that's part of the problem with these word problems, is really dissecting them and making sure that we understand what they're actually trying to tell us in the problem. You can't solve the problem if you don't even know what the problem means, right?
Right.
But again, you can catch yourself. An easy mistake to make is to switch these two numbers. So make sure that this is money plus money equals money.
Right.
And this was pounds plus pounds equals pounds.
Right.
One thing that often happens is that we have like a primary and a secondary. We solve one equation for one variable, but an easier way to solve equations with two variables is I'm going to go ahead and solve that for one of my variables. And then I'm going to plug that into this equation. So it doesn't matter which one. Do I want A equals or B equals?
You can do B equals.
Okay. So B equals, and then what would I get? What do you do to both sides so that when you're done, you just get B equals?
Would you subtract?
Yeah, just subtract A from both sides. Okay, and one of the things that I see people do wrong is they make a bad guess right here. It's a good guess. It makes sense. It's an educated guess, but they make the wrong educated guess. So go ahead and write out your educated guess and then check it and see if it actually worked. You know, in this case, it's just when I combine like terms, do I get what I thought I got? So I'm going to take 455A plus 590, but I have that B is 180 minus A. So I'm just replacing my B with that. So I got 4.55A plus, I'm going to have a minus A on that side, but that should work itself out. What's 5.9 times 180? Anyone?
Oh, sorry, my mic was muted. It's 1,062. I think your microphone muted.
I don't know how someone must have the ability somewhere to mute that, so. Okay, you're there, I touched something weird and it happens. Okay, are you with me? Does that make sense?
Yes, yes, for sure.
Okay. And so then we double check and we make sure we know what question was asked. And let's see, I lost my picture, so I'll open it back up. It wanted to know how many pounds of coffee A. We're actually done. And that's a benefit of writing down what our letters stand for, is that I know that A was the coffee from type A. And so I don't have to do any more work. Sometimes you have to do more work. Sometimes you have to go back and use stuff that you've written down already to find the other answer.
Right.
In this case, we should be done with that question. But, you know, back up to key ideas. Number one, be careful with being clear with what your variable stands for. So again, I do this a lot if I'm teaching this in a class. I'll say number of, you know, that can help you keep your bearings. Number two, you know, go through little pieces and remember what those little pieces stand for. So when you're writing an expression down, make sure you know what that entire expression is calculating. And then keep that in mind when you're writing your equations. Make sure that you're, you know, adding apples and getting apples, etc.
Okay. Thank you.
You're welcome.